When an activity is running in Android, it can be killed for numerous reasons. The user could hit the back button. The programmer may close the activity with a call to the finish function, or Android may kill the activity for a couple of different reasons. It may kill the activity because it's a part of an application process that is being killed to reclaim resources such as memory. Or the activity may be killed and restarted because the device undergoes a configuration change, such as rotating the device from portrait mode to landscape mode. When that configuration change occurs, Android does an activity restart, essentially allowing the activity to reload new resources that match the current configuration. However, this process is a destructive one because it causes the activity to lose whatever state information it was holding onto. That state information can be anything from data entered into views, as well as data such as objects, primitive values, etc., that you might have declared and have been storing in variables and other references inside your activities class. Now, Android will actually help you out to some degree in that for some of its view elements where it expects data to be changed, such as an edit text, Android will actually retain the data, which may actually cause you to think that there is no activity restart happening. So here I enter a name and I do a rotation, and I see that the data itself is preserved. Do another rotation, and again, the data is still held. But not all views will have their data retained in this way. So let's take a look at how we can actually retain the data ourselves, even in cases where Android doesn't do it for us automatically. We'll start by setting up this application to follow the behavior that is implied from the layout, which is what we would like to do is have this text view change its message to tell the user that types their name in hello whenever this button is clicked. So to do that, we'll first bind our views, and I'm going to do this both using local values as well as properties, and that is because I'm going to need to access some of these views from different functions. Specifically, I'm going to need to access my text view from a few different functions. So I'm going to declare this above, and then I will give it a reference to the text view. And then I'll declare my other views locally. So my edit text, and I don't need a variable for my button. I can just go ahead and apply an onClick listener, since I only need it to trigger a specific action. All right, so the goal here is to have the text property of the text view be changed to a message. Let's just say hi, and the name that's entered in the edit text. And that's probably as straightforward as we need it to be. Let's take a look at our app in action. So what I'll do here is type my name, and then I'll hit the button, and it says, hi, Kevin. So works exactly as we would like. So I have the value Kevin typed into the edit text, and the text view above it is showing the message, hi, Kevin. Now look what happens when I do a device rotation here. Notice that the edit text, just as before, retains the value Kevin. However, the text view has reverted to its original value that was specified in the layout file. This is because Android essentially doesn't expect the values in text views to be changed necessarily. So it doesn't automatically retain that data, whereas an edit text, its entire job is to have text be entered. So it essentially includes the implementation to hold on to that data, retain that data when the activity restart occurs. So if we would like this text view to also retain its data, which is exactly our intention, we're going to have to do that ourselves. So to do that, I'm going to introduce two new functions that are a part of the activity lifecycle. The first is onSaveInstanceState, and the second is onRestoreInstantState. Now these two functions work together. First, onSaveInstanceState has the responsibility of allowing us to specify data that we would like to retain across activity restarts by simply placing it in this bundle object. So this bundle is a container where we can place all types of data, primitive data types, collections, as well as objects that have implemented either serializable or the bundle interfaces. On the other side of the coin, whenever information is stored in the bundle object via onSaveInstanceState, when an activity restart occurs, onRestoreInstantState will be invoked, and it will be provided with a bundle object that will contain the data that was placed inside the bundle given to onSaveInstanceState. So basically, before an activity is destroyed and prior to it being restarted, Android will invoke onSaveInstanceState on the activity, giving you a bundle and basically saying anything that you would like to save, place it in this bundle and I'll hold on to it. When the activity restart occurs, Android takes the information that was in that bundle and passes it to you again in the new instance of the activity by invoking onRestoreInstantState. Interestingly, onCreate also receives a bundle, but in this instance it's nullable. But this bundle object that is passed into onCreate will actually be the same bundle that is passed to onRestoreInstantState. So it turns out, even though to save data you must use the onSaveInstanceState function, when it comes to restoring data, you actually have a choice between onCreate and onRestoreInstantState. And which you choose actually depends on how you perceive your initialization process, your state initialization process. For example, oftentimes onCreate is used to do default setups, and onRestoreInstantState is used to override those values with information from a previous instance of the activity if that data exists. However, you may simply opt to use onCreate only and only do the default initialization if no data existed prior, meaning there was no previous instance of the activity where data was saved. All right, so that's sort of the theory behind the whole thing. Let's actually look at the implementation. So in this case, what we want to do is retain the text value of the text view inside the bundle object that is passed to onSaveInstanceState. To do that, we will simply, using a key value pair mechanism, place information inside the bundle. In this case, we'll call putString, since that's the data we would like to retain. And we need to provide a key. That key needs to be a unique string. And then we provide the data that we would like to save. So in this case, it would just be textView.text.toString. Now, in this scenario, I'm using a string literal as a key. This is actually considered very bad practice. Essentially, because whenever you use a string literal, you're opening up the possibility of introducing errors by typos, or at the very least, giving yourself additional work to double check what the reference is by having to go back to the original source where the information was being stored. The proper way to do this instead is to use some kind of reference. That reference can be just a simple private value if you intend to use this key only within a single class. If you intend to use it in other places in your application, meaning you may use the key to store information in one component but retrieve it in a separate component, then you can use either a constant value or you could use a value defined inside of a companion object. And using a companion object at least allows you to maintain the namespace. So that can actually help you discern what the key is referencing versus a constant value, which just has global scope and it's not necessarily obvious what the key is defined for unless it comes from the name itself. So for this instance, we'll just use a simple local value. So we'll just have a value. We'll call this name key. Not the most creative names, but it's fine. So name key is then going to be used for the key here. And that's it. The information gets saved. And then all I need to do is in onRestoreInstantState is access the value from the bundle by calling getString. The string I want can be looked up with name key. And because this is nullable, I'm not sure if it will be there, so I will say if it's there, then I will use it to initialize the text view's text value. So this will essentially override the default value that will be set by the layout. Alternatively, this logic could be moved to my onCreate function. The only difference is in onCreate, I will have to check if the bundle object is not null or do something similar to this, because onCreate may or may not receive a bundle depending on whether or not information was saved prior, whereas on onRestoreInstantState, the bundle is not nullable because onRestoreInstantState is only called if onSaveInstanceState was invoked and information was placed inside the bundle object. So running our application now, as we type Kevin and hit hi Kevin, and now when we do a rotation, we see that the data is retained. So again, this can be extended to store all the state information from our activity, not just information relating to views. And it's how we can ensure that if an activity restart occurs, our state information is not lost.